Hello everyone, welcome back to my channel. Today's topic is just a part of my previous upload, which was the 555 timer, but this time I will only focus on how to increase or lengthen the time of the output on a high state. Alright, this is our 555 IC. Our objective is to increase the time high. Increasing the time high doesn't mean that you have to change all the values of these components. No, it's not. Increasing the time high can be achieved through the change of values on this R1. Alright? Try to look at on this equation. Time high is equal to ln times 2 times R1 plus R2 times C1. For time low, changing the time high or increasing the time high does not affect the time low. It's because in time low there is no R1 on the equation. We will concentrate on the time high because that is our objective. If you change this R1 or increase this R1 of different values, of course your time high also will increase because they are directly proportional. Go back to the circuit here. For R1, I choose 4 different values to install. First one is 2 kilo ohms. Second is 5 kilo ohms. The third one is 10 kilo ohms, and the last one is 20 kilo ohms. I will install this resistor one at a time. Okay? I have 4 different calculations according to the values of each resistor. This column is the calculation of 2 kilo ohm resistor, and this column also is 5 kilo ohm resistor. Here is 10 kilo ohms resistor, and the last one is the 20 kilo ohms resistor. But we will start on the 2 kilo ohms. As mentioned earlier, the time high is equal to ln times 2 times the total of R1 plus R2 times C1. We will substitute time high is equal to 0.693 times 2000 plus 2000 times C1. Time high 0.693 times 4000 times 0.000200, and our result is 554 milliseconds. By the way, for this 0.693, don't be confused. That is the result of ln 2. You can use your calculator. Therefore, when you connect a 2 kilo ohm resistor in R1, your time high is 554 milliseconds. Time high means is the length of time that your output is in a high state. High state means your LED is on. Next is time low. Time low is equal to ln times 2 times R2 times C1. Substitute 0.693 times 2000 times 200 microfarad, and our time low is 277 milliseconds. Time low means is the length of time that your output is in low state. Low state means your LED is off. The LED that I am referring to is this one. It is connected to the output of the 555 IC, and since LED is not enough, I'm going to connect an oscilloscope here between this output, and let me show to you in the actual circuit. This one. So this is my R1. Other components will not be changed except only for this R1. Now I will connect this probe from the oscilloscope. First from the negative point, and this one to the output of the clock. This one, and I will show you the actual waveform. Alright, in the waveform, that is very obvious that the time high is longer than the time low. Alright, so this is the time high and the time low, and the value for the time high is this one, 544 milliseconds, and we will compare to my calculation. See, the time high is 554 milliseconds, and in the oscilloscope is 544 milliseconds, right? So there is just a very little difference that is due to the tolerance of the resistor and other factors. The value of time low is this one, 268 milliseconds, but that is oscillating, and compared to my actual calculation, this is 277 milliseconds. Okay, now we have done the 2 kilo ohm resistor. I will proceed to the 5 kilo ohm resistor. So this is my 5 kilo ohm resistor, this one, and I will replace to the R1. I will remove the 2 kilo ohms and has to be replaced with 5 kilo ohms. This one is not easy to connect. Okay, so this is my 5 kilo ohms now, R1, and I will put the power here. Now I will show you the waveform on the oscilloscope here. So our time high and time low. Look at our time high, 970 milliseconds, and I will compare with the calculation. Alright, for 5 kilo ohm resistor, the time high becomes 970 milliseconds, but our time low stays the same. Nothing changed. As I mentioned before, time low is not affected, only the time high. Okay, go back to oscilloscope. Alright, now we have done the 5 kilo ohm resistor, we have done the 2 kilo ohm resistor. We will proceed to the third value, which is the 10 kilo ohms. So for 10 kilo ohms, the time high should be 1.663 seconds. Okay, so I will get this 10 kilo ohm resistor and I will replace the 5 kilo ohms resistor. Take out the 5 kilo ohms and replace the 10 kilo ohm. Okay, ten kilo ohms resistor is now connected, and I will show you the waveform on the oscilloscope. That's it. Okay, so look at this. The time high is 1.630 seconds or 1.6 seconds, and our time low stays the same. And we will compare to the actual calculation. See, time high is 1.66 seconds and time low, as usual, is not affected. Go back to the oscilloscope. That's it. Alright, so we have done the 10 kilo ohms resistor. We will proceed to the last one, which is the 20 kilo ohms resistor. For 20k, the time high should be at 3.04 seconds. Alright, and I have this 20k. Since I don't have a 20k resistor, I connected two resistors 10k in series. Okay, so I will put here and replace the 10k. Take out the 10k and replace with 20k. Okay, that is our 20k resistor. I will connect the power. That's it. So we will go back to the oscilloscope and I will adjust the time division for a better viewing. Okay, that's it. Alright, so look at our time high. Time high is 3.02 or 3 seconds run off, and the time low stays the same. And we will compare to the calculation. See, 3.04 seconds, time low stays the same. Alright, so with those 4 different value of resistor R1, the time high is increasing according to that value, right? So as you observe, from 554 milliseconds it becomes 970 milliseconds and it becomes 1.6 66 seconds, and it becomes also 3.04 seconds at 20 kilo ohms. So you can do this experiment. If you will add some resistor here, you will connect 30 kilo ohms, 40 kilo ohms, and so on and so forth, and you can see the trend of the time high. It will also increase, but your time low Bs stays the same. Alright, thank you very much for watching, and I wish it would be of great help as your reference in the future.